Alrighty. The rod, the strut, is connected there, right? Okay, so presumably this strut is going to exert a force that's in that direction, if I could actually draw the line parallel to that, right? Okay, so it's actually going to have a force, we'll just call it force, right? It's going to have a x component, let's see, this is 38 degrees, right? So therefore this is also 38 degrees, because they're opposite angles, right? So this would be f cos 38, right? It's positive, it's in the positive x direction. Then we've got f sine 38. And this is just SOHCAHTOA. This is the opposite side, right? This is the adjacent side. All right, so that's one of the forces. Obviously, we've got the force of gravity down. We've got 3G. Let's see the rod. The box is centered 1.20 meters from the left side. So this is 1.2 meters. All right, the beam is, it's a 4 meter long beam, right? So the other force is, of course, the force of gravity. We've got 4G, 4 times 9.81, right? This is 3 times 9.81. 4G at, it's a 4 meter long beam, so that's at 2 meters, because it's at the center. Okay, what other forces? Oh, we still have the force of the wall. The force of the wall in the y direction, and the force of the wall in the x direction. All right. So those are all our forces. We've got the force of gravity of the box, of the beam. We've got this strut pushing up like that. This line really should be parallel to that, but I'm kind of learning how to use this pen. And then we've got the wall. Basically for the wall, you just say the wall pushes in the y and in the x, and we'll figure that out. Okay? All right, let's see. Be sure to give the direction of the components. Okay, so let's set up our x expression. Our x expression is wall in the x direction plus force times cos 38 equals 0, right? So the wall is actually not going to push to the right. The wall will actually be pulling this thing to the left, simply because this strut is pushing to the right. The wall will pull to the left. So we'll end up with a negative number there. I like to do it that way. You can do it any other way you want. And then let's set up the y expression. Let's see, we've got the wall in the y direction. We've got minus 3g. We've got minus 4g. This is the weight of the box, the weight of the beam, right? And then, of course, it has to be supported somehow, right? So plus f sine 38, right? So this component here is lifting it up, and then that's got to add to 0. And then let's torque about the left side. Okay, so that torque is 0 times the wall in the y direction. Now let's see, plus the box is going to be a clockwise torque, right? So plus, where is that? It's 1.2 meters from the left side, so plus 1.2 times 3g. All right, and then we've got plus, it's at 2 meters, right? Because that's the center of the beam. The beam is 4 meters long, and the force of gravity would be acting right at the center, which is 2 meters from the left side. So 2 times 4g. All right, and then we get to the very complex thing of this force, right? The rod is connected 3.2 meters, right? So that's at 3.2 meters, right? So we say this is an anti-clockwise torque, right? So minus 3.2 times f sine 38. And all of this equals 0. All right. And then, of course, again, we can cross that guy off and solve for our force here, which is what I'm going to do. So I'm going to go 1.2 times 3 times 9.81. All right, plus 2 times 4 times 9.81. All right, get that answer. And then I'm going to divide by 3.2. and divide by sine of 38. I'm getting 57.76. Right, so that would be 57.8 newtons. Right, and like a tension, a strut can only push it. I guess it could pull too, couldn't it? Yeah, anyway. All right, but we definitely know that that thing's got to push in the direction, in that direction. Right? All right, so now let's set this guy up here. Let's go wall in the x direction. We'll substitute 57.761 for that. So wall in the x plus 57.761 cos 38 is 0, right? So if I go times cos 38, 45.516 of the wall in the x direction is negative 45.5 newtons, right? So the negative means to the left. So I would say it's 45.5 newtons left. All right, and then finally we'll figure out what the wall is in the y direction here, right? So we get the wall in the y direction minus 3 times 9.81 minus 4 times 9.81, right? Plus, and then we know the force is 57.761. All right, so let's figure out what the force is in the y direction. So 3 times 9.81 plus 4 times 9.81. Get that answer, right? And then I think I divide by this. And then, oh, no, don't divide. I'm going to subtract that. Minus that times sine of 38. All right, here we go. Having a hard time here. Okay, I think I got it. 33.1. The wall in the y direction. Now the fact that I get a positive number means that it's up. Ta-da.